This is Unit 4, Lesson 3, Part 1, Rates of Change and Other Applications. In the first part of this unit, we've talked about rates of change, which have related to topics we discussed in the first 3 units. We're going to move away from that now a little bit, and we're going to talk about rates of change for other applications. And one of the big ones we're going to talk about is economic scenarios, because I know many of you plan to pursue a business career of some kind, and business calculus is required for a lot of those majors, and they focus more on economic relationships in calculus than more physical ones that are traditional. Okay, so some vocabulary that we need for this economic scenario is a cost function. It gives the total cost of producing so many units. And then we have an average cost, which whenever you're doing average, those of you who have statistics will understand the bar on top of the C. That usually means the average or the mean. So we're going to find the average cost function by taking our C and dividing it by X. And of course, that's going to include our fixed operating costs. Then we have a revenue function, which is the total net revenue received for the sale of the units. We're going to keep that pretty simple in this lesson. We are going to usually just have an item that costs so much, and we're going to multiply that times the number of items. And then, of course, we have our profit function, which is found by taking the amount of revenue we generated and subtracting off our costs. So in terms of function, we use pi for profit. So pi of x is going to equal r of x minus c of x. And it says, please note, in the business world, the Greek letter for P, that is pi, is commonly used for profit. This helps to have different variables for price, profit, and pi. So that's why they use the pi. Okay, so let's talk about marginal analysis and nonlinear functions. In marginal analysis, we have a method for estimating how revenue, costs, and profits change. The input increases by one additional item. So if the graph of a nonlinear function is not curving too rapidly, so it's not like it has a nice smooth behavior, we can use the slope of the tangent line to give a close approximation of how these quantities change in a relatively small amount of change, or in the neighborhood. Then we have something called marginal cost, which is the derivative of our cost function, and it approximates the cost to produce one more item. So in other words, it's the additional cost at the margin. That's why it's called marginal cost, because we're already at our margin, which is the window we want to be at. So how much more are we going to have to spend? So to find an exact amount to produce one more item, what you're going to do is use the original cost function at the new item and subtract off the cost at the items you were before. Okay, so the marginal cost is not going to be completely accurate. So let's do an example. So example 1 says the cost to translate documents into another language is a function of the number of pages. The cost function is given by C of P equals 0.002 P to the third minus 0.1 P squared plus 8.75 P. So we're supposed to calculate the marginal cost for translating 10 pages. How does this compare to the actual cost to translate 10 pages? So if we want the marginal cost, we need to find the derivative of the cost function. So C prime of P is going to equal, we're just going to use the power rule here. So 0.006 P squared minus 0.2 P plus 8.75. So we want C prime of 10, so we're going to substitute 10 in. And another thing to note here why I'm writing this is that for a lot of these problems, these will be in the calculator section. So what you get then is it's going to cost, the marginal cost will be $7.35 per page. Okay? Now the exact cost is going to be, we're going to find out how much it would cost to produce 11 pages and subtract that, the amount that it would produce 10 pages. That'll give us the change in page amount. So when I'm not going to show the math, but I'm just going to substitute 11 in here for p cubed, p squared, and p. And C of 11 is $86.81. And C10 is going to be $79.50. So the actual marginal cost is $7.31 per page. Okay, so what you can see here is there is a 4-cent difference. So it's pretty close, but it's not exact. Because if you take your cost for producing 11 pages and subtract from that how much it costs you to produce 10 pages, you're going to get your exact marginal cost. Okay. So let's look at a graph now. All right, so example 2 shows us a graph, and it says use the graph at right to show the relationships for average cost and marginal cost. Okay, so some things to point out here on the graph is, first off, that right here, this is our fixed costs. So even if we don't produce anything, that's things like your rent, your electricity, any supplies or employee costs that you have before you produce one item. All right, now I labeled 2 other points here, and what we have is we have here and here. And what this is showing us is this is the cost to produce one more unit if you go from one point to the next. So this is the cost to produce one more unit. Okay, and then what you're going to notice here is that we have a couple of tangent lines drawn, and the difference here between where we really are, sorry, I'm a little trouble saying that, where we really are, so we have this little difference right here. This is very small, which is good. And this is like our C prime of 100, because you can see on the x-axis I labeled 100 units and 101 units. So that would be our C prime of 100 right there. Okay? And you can see it's a small increase. And then, so what we're seeing is from here to here, that point over, let me label this a little better, that's this here. So this green part here, we're going to call that our estimated marginal cost. Let me use a different color. So this right here, this little section right there, this is our estimated marginal cost. Okay, so that's the estimated one. Let me write estimate a little better. That looks a little bad. Okay, the purple here, this is our actual marginal cost. Okay, so that's what you're seeing visually on the graph. Okay, so example 3 then. We have the cost of producing a set of Bluetooth headphones is given by the production manager as C of X equals 1500 plus 50X plus 0.01 X squared. So we're supposed to find the marginal cost function, then use this function to estimate how fast the cost is going up if the company produces 100 sets of headphones. Okay, so our marginal cost is going to be the derivative of our cost function. So that's going to be 50 plus 0.02x, and then we want to know what would happen how fast, if we're at 100 headphones, how fast is the cost per item going up? Because we may not want to increase production if the costs are just too high. So C prime of 100 is going to be 50 plus 2. So that's going to be $52 per headphone. So each additional one at 100 headphones is going to cost us an extra $52 to produce. Okay, so let's find the exact cost of producing the 51st headphone. So what we're going to do is we're going to take C of 101 headphones, and we're going to subtract from it C of 100 headphones. So let's go ahead and do that. So we're going to have 1,500 plus 50 times 101 plus 0.01 times 101 squared. And when you do that, you get 6,600, $66,501.01. And C of 100 is going to be, writing it out real quick, $6,600. So our actual marginal cost is $52.01. So we're pretty close. So that's going to be, this is to produce, let me put that over here, to produce the 101st headphone. So our marginal cost function was pretty close for this example. Okay, part C, find the average cost, C of X bar, and evaluate C bar of 100. Explain the meaning and context. So just to recall, our average cost function is going to be, whoops, C of X over X is C of X bar. So C of X was 1,500 plus 50X plus 0.01 X squared. We're going to divide that by X. So we get 1,500 over X plus 50 plus 0.01 X. And then we just have to substitute in 100. And when we do that, we get $66. So what does that tell us? What that tells us is when 100 headphones are produced, the average cost to produce one more is $66. And I'm going to stop here with part 1, and we'll continue our discussion in part 2.